ratios for any triangle, right? We didn't even know how many degrees theta was. We just knew 2 of the sides, so we were able to find the third, set up all of the ratios, right? Today, we're going to talk about special angles within our unit circle. So, in geometry, we talk about 2 special right triangles. Okay, so that's what we're going to be talking about today. First, it says they just want us to go through and name the endpoints and then use the unit circle that is going to have a radius of 1 unit to help you find the values of the quadrantal angles. Okay, so we're just going to go through and put points right here on our axis so that we can provide the coordinates of the quadrantal angles. Your quadrantal angles are going to be the angles that are formed right on your axis. Okay. So right here, if I am at this point, looks like we've gone over 1, right? But have I gone up or down any? No. So this would be the coordinate point 1, 0. It's 1 because they told us R was 1. And remember, if I'm starting there and it looks like I haven't gone up or down any, that's also my R, right? Remember, R was this vector that we had yesterday. Well, it looks like my vector is right here on this line. It hasn't gone anywhere yet. All right. Okay. All right, if I'm right up here, this is at pi halves, right? At pi halves, looks like we've gone up 1, but we haven't gone left or right any, right? So this would be the coordinate point 0, 1. Okay, over here at pi, what would that coordinate point be? Negative 1, 0. Good. Because we know x is going to be negative over there. All right, what about down here at 3 pi halves? What coordinate would that be? 0, negative 1. Good. And then if I'm back to where I started, then I'm back at 1, 0, right? Okay. All right, so we knew all this was 1s because they told us that R was 1, right, which is just that vector we talked about yesterday. So now that we have these coordinate points, they want us to go and provide the ratios for each one of these. Okay, well, remember sine, we said with our new letters, is y over r, right? Okay, so we're looking for sine of 180. 180 is right here at pi, right? Right over here. Okay, so what is the y value there? 0. And what did they say r was? 1. They said that the radius was 1 unit. Okay, so it's 0 over 1 as the ratio, which simplifies to just 0, right? Okay. Cosine of 90 degrees, that's pi halves, right? So up here, cosine's ratio is x over r, right? And what's the x value at pi halves? 0. And what is r? 1. So cosine at 90 degrees is just 0. All right? Then they asked for cotangent of 270. Remember, cotangent is just the reciprocal of tangent, right? So if tangent is y over x, cotangent is x over y. Okay? So for x over y at 3 pi halves, what are we going to have there?
0 over negative 1.
Right. Which simplifies to
0.
right. Okay. Number 4 is asking for tangent at 90 degrees, or tangent at pi halves. So tangent is y over x. What's my y at tangent of 90? 1. And what's x? 0. Okay, so this is different. Am I allowed to have 0 in the bottom of a fraction? So my ratio here is undefined. Okay? Then we've got cosecant of pi halves. Remember, cosecant is the reciprocal of sine, right? So this would be r over y. So at pi halves, what is r over y going to be?
1 over 1.
1 over 1, which is really going to simplify to just 1, right? Okay. Then lastly, we've got secant of 2 pi. Remember, secant is the reciprocal of cosine. So this is r over x. So at 2 pi, r is still just 1. And what's x at 2 pi? What's x at 2 pi? 1. And 1 over 1 is just, yeah, remember in our coordinate points, guys, this is x and this is y, right? Okay. All right, so these are not too bad because it's just either a coordinate point 1, 0 or 0, 1, and your signs change depending on where you're at, right? Okay, so now let's take a look at those special right triangles. So in geometry, we had talked about a 30, 60, 90 triangle. Okay, and we had said that there are specific measurements that you can put on the sides because they should all be proportional, right? They're all going to have those measurements. Okay, and those side ratios are 1, square root of 3, and 2. We used x square root of 3, and 2x because they could change. But on our unit circle, if r is always 1, it should just be 1, square root of 3, and 2. Okay? These are going to occur at these places on your unit circle. Right? Because all of these measures are, this one is 30 degrees, right? This one is 60 degrees. And this one is 90 degrees. So these are the places where I could have my right triangles. Okay, so they drew a 60-degree triangle for us right here. I'm going to draw a little coordinate grid to put that on. Let me draw that a little closer. So if this were on a coordinate plane, this is what it would look like. They also, instead of putting 60 degrees, could have also put pi thirds right here, right? And I should know that those mean the same thing. Okay, so they lined it up for us, the ratio. So at 30 degrees, so across from 30 degrees, that's the side that should be 1, right? Okay, across from 60 degrees is the side we're supposed to label square root of 3. So if this is the 60 degrees, over here is where I should have square root of 3, right? And then across from 90 degrees is 2. So I could have 2 here, and then I should have 1 down here. Okay? And now that I have all 3 sides, I can do exactly what I did yesterday. I can provide the ratios. So now it's not sine of theta. We know how many degrees it is. It's sine of 60 or sine of pi thirds. Okay, and the ratio for sine is y over r. So what is y over r going to be here? Over
1. So just square root of 3.
wait, over 2, right? Because r is the hypotenuse. Okay. Cosine of 60. This one is x over r. What's x over r? 1 over 2. Good. All right, and then we need tangent of 60 degrees. So tangent is y over x. What's that going to be? Good. Or just square root of 3. All right, and now we need the reciprocals. So I'm going to start with cosecant, which is the reciprocal of, not theta, cosecant of 60, which is the reciprocal of sine, right? So that would become 2 over root 3, but do I leave square root of 3 in the bottom? So what's that one going to be? Good. All right. And then we need secant of 60. So this one is the opposite of cosine. So what would this one be? 2. Good. And then lastly, cotangent of 60, which is the reciprocal of tangents. What's that one going to be? 1 over root 3. but we don't want to leave root 3 in the bottom, so it becomes over 3. Good. Okay. All right, and then we got another one drawn for us. I'm going to make this one on a coordinate plane as well. Okay. So they said that this angle is 30 degrees. They also could have said that as pi 6, right? What do we label the side across from 30 degrees? 1. Okay, and across from 90 degrees? 2. And then this must be the 60-degree angle then, right? So across from that, we label it square root of 3, right? Okay. So now we're going to provide the ratios for 30 degrees. So I'm going to have sine of 30 degrees, which is going to be y over r. What's y over r here? 1 over 2. Okay, and then cosine of 30 degrees would be x over r, which is going to be square root of 3 over 2. Okay, and then what about tangent of 30? Right, 1 over root 3, which we have to simplify to root 3 over 3. Good. All right, then we need those reciprocals. So we're going to do cosecant of 30 degrees. What's that one going to be? 2. And then we need secant of 30 degrees. What's secant of 30? Good. And then lastly, we need cotangent of 30 degrees, which is going to be square root of 30. Nice. Okay. So the reason that we only need these two triangles, one with 30 and one with 60, is because all the way around the unit circle, it just repeats itself, right? It just increases by increments of 30 degrees. Okay, so if I were to have, let's say, an R right here, okay, so I know this is 120 degrees, right? Because I would have gone 30 degrees from 90 right here, okay? But remember, whenever I would draw my triangle, it's going to be this way, right? Okay. So my theta, I'm not asking how many degrees this part is. I'm asking how far it is from here, right? Okay, so if from here to here is 30 degrees, then theta in this triangle would be 60, right? But if I did it 30 degrees further, if my line actually was over here, at 150. Then my theta would be 30 degrees, right? And it's just going to be the same triangles repeating themselves all the way around the circle. The only thing that changes is in some quadrants, x might be negative or y might be negative, right? Okay, so that's what we call cofunctions. It says cofunctions have equal values when their angles are complementary. So, for example, 30 and 60 are complementary. Remember, complementary just means they add up to 90, right? So they give some examples. They say, like, the example sine of 60. Well, sine of 60 we had right here. That was square root of 3 over 2, right? Is equal to cosine of 30. Well, we found cosine of 30 here. It is, in fact, the same thing, square root of 3 over 2. So those ratios are the same because these are complementary, okay? So therefore, sine of theta is equal to cosine of 90 minus theta. So they're going to be reciprocals of each other, okay? All right, flip it over onto the back, and we're going to talk about our other type of special right triangle, which is our 45, 45, 90. Okay, 45, 45, 90 is the same as pi force, pi over 2, right? Because pi force is equivalent to 45 degrees and pi halves is equivalent to 90 degrees. And it also gives us the side measurements for these. It says when you have a 45-degree angle across from it, you label it 1. Across from 45, again, we label 1. And across from 90, we label it square root of 2. Okay, so I'm going to put this triangle on a coordinate plane. Okay. And if this is 45 degrees, so is this, right? And across from our 45-degree angle sides, we label them 1 and 1. And we label our hypotenuse square root of 2, it says, right? Okay, so now that we have these measurements, we should be able to come up with our ratios. So we're going to start with sine of 45 degrees. Sine is y over r, right? So what's y over r for us? Right. 1 over root 2, and then we have to simplify. Okay? So cosine of 45 degrees. X over r should be the same as y over r, since x and y are the same. So this is also root 2 over 2. All right, tangent of 45 degrees. This is y over x, which is just going to be 1. Okay. And then we need their reciprocals. So cosecant of 45 degrees. So this is r over y, which would just be square root of 2. Secant of 45 degrees would just be square root of 2. And cotangent of 45 degrees is 1. Okay, there's only one 45-degree angle in each quadrant, right? The one right in the middle. So if it were drawn, for example, in this quadrant here, this side might be 45 degrees from 90, but this side would also be 45 degrees, right? So my theta is 45 degrees. The only thing that's going to change is that instead of a positive 1 on the x-axis, I'd have a negative 1, right? So the ratios are going to be the same. The only thing that could change is some signs, right? Okay, so here they ask us to find each of the following. So they ask for sine of 30 degrees. Okay, so you do not have to draw a triangle out every time, but that is what you should be thinking up in your head. Okay, so 30 degrees is in quadrant 1. So it would look like this. And my 30-degree angle would be here, right? What do we label the side across from 30?
60.
The side.
The
1. Okay, and then this is 60-degree angle here. What do I label the side across from 60? Square root of 3. And across from 90, what do we label it? 2. Okay. So when I ask for sine of 30, 30 is my reference angle, right? And I'm being asked for y over r. Right. Okay. Tangent of pi thirds. What quadrant is pi thirds in? The first one. Okay. And pi thirds is equivalent to how many degrees? 60. So this one looks something like this. And again, across from 60, what do we label that side? Square root of 3. And they're asking for tangent, so the only other side I need is x, which would just be 1. So y over x here is just going to be nice. Okay, sine of pi. Where is pi? Right, it's over here on the negative x-axis, right? So remember that was the coordinate point, negative 1, 0, where r equals 1. So if they ask me for sine, they're asking for y over r. What's y over r going to be? 0 over 1, right? R is positive 1. R is always positive, right? But 0 over 1 is going to simplify to just 0. Okay? Pi fourths. What quadrant is pi fourths in? 1. Okay, so I'm going to draw a 45, 45, 90 triangle. And what do we label the sides across from the 45-degree angles? 1 and 1, and the hypotenuse is square root of 2. All right, so when they ask for cosine, that's x over r. What is x over r going to be? 1 over root 2, but we simplify, so that would be good. All right. Then they ask for secant of pi 6. What quadrant is pi 6 in? 1. And pi 6 is equivalent to how many degrees? 30. Okay, so I've got a 30-degree angle right here. What do I label the side across from 30? 1. And then my x here would then have to be square root of 3, right? And then the hypotenuse 2. Okay, so secant. Secant is the opposite of cosine. So I need I need r over x. What's r over x?
2 root 3 over 2.
Good. 2 root 3 over 3. Okay. All right, and then this one it deleted. This is supposed to be pi halves right there. Cotangent of pi halves. Okay, so pi halves, that's on my positive y-axis, right? So what's that coordinate point? 0, 1. And remember, r is always 1. So cotangent, we don't need r. We only need x and y. So what is x over y going to be? 0 over 1, which is just good. Okay. All right, so here they ask us to solve for x on these two figures. So I'm going to have this that I'm going to pretend is on a coordinate plane. Okay, so that means I should be able to set up my ratio. So they gave me x and they gave me 10, which is this side we call r, right? Which ratio uses x and r?
Cosine.
Cosine, okay? So I could set this up as cosine of 60 degrees is equal to x over r, which we know to be 10, right? Okay. Well, in our figure, we should know that for cosine of 60 degrees, if you flip it back over, cosine of 60 degrees is what ratio? 1 over 2. So I can replace this with 1 over 2 because I already know what its ratio is and set it equal to x over 10. And then this is something we would just cross multiply and solve, right? So here I would have 2x. Here I have 10. X is 5. All right. Okay, let's do one more of those. So over here, this one's a 30-degree angle of theta. We were given y and then 100, which is like x, right? So which ratio uses y and x? Tangent. Okay, so we're going to have tangent of 30 degrees is equal to y over x, which is 100. So flip it back over on the front. What's my ratio for tangent of 30? Square root of 3 over 3. So I'm going to have y is equal to, square root of 3 over 3 is equal to y over 100. And then I'm going to cross multiply. So I'm going to have 3y is equal to 100 times square root of 3, right? And then what would I do to solve? Divide by 3. So y is equal to 100 root 3 over 3. Okay, we don't want the decimal answer, so we are going to keep it exact. Okay, so eventually, guys, our hope here is that we will have these ratios memorized and these ratios right here memorized, and then I won't have to draw the triangles every single time like we did in this section, okay? And we will add those on to stuff we have to memorize on our unit circle next week.